Okay, so this is a simple Excel calculator which has the relation between the skin factor and a well productivity index multiplier or WPIMULT. So in this file you will see two tabs, charts and equations. In the equations tab, I derive that PI multiplier starting from the inflow equations, and I have developed here the old-fashioned way by hand using two inflow definitions. One is Darcy. I'm actually quoting the very page I'm taking the equation from in Dake's book, but also in parallel I'm using the eclipse definition because it's in a simulation his rematching exercise where you typically do apply a WPIMULT. So I want to understand the relation between that multiplier and the skin factor, which oftentimes it's a more intuitive parameter to understand for many people. Okay, so you can just follow the derivation here, but basically I arrive at two um, expressions for that skin factor as a function of the WPIMULT, one using Darcy inflow equation, and the other one is using the eclipse definition. Okay, and as you can see, this is for the final skin value, which depends on the initial skin value and the WPI mult. Okay, so using those two relations, we can build these charts, right? So there are a couple of inputs that the user needs to enter into these yellow cells. For example, let's say 300 acres per area. Let's leave the well radius, or let's change it just so you can see that after changing those two key inputs, then we can calculate these tables which contain the final skin value for a range of initial skins or S0 and a range of WPI mults. So this button triggers the macro that calculates precisely that final skin value as a function of that initial skin and WPI mult. So if I click that button, the table is recalculated and the chart is updated accordingly. Likewise, on the right hand side, I have exactly the same, but now using the eclipse definition, not the Darcy definition. Now you can obviously use the same values. Actually, I have them in orange as a reference of the yellow cell, so I'm using the exact same values, but if you recalculate that table, the chart updates accordingly, and now these are the curves that give you the final skin value for a range of skins and a range of WPA mult. For example, if the initial skin was 5, so S0 equals 5, that means let's move along this curve, okay? So your initial skin was 5, and what this means is if you apply a multiplier, a WPI mult of 2, so we move to this axis, that is equivalent to having a final skin of somewhere in the region of minus 1.5, starting from 5, right? So we double the productivity. We went from skin 5 to final skin minus 1.5. Likewise, if our initial skin was, for example, minus 5, that means we move along the blue curve, okay? And our WPA mult is now 0.5, that is, we have the productivity. That means now our final skin is somewhere in the vicinity of minus 2. So we went from minus 5 to minus 2 by halving the productivity. Okay, so actually we're increasing skin because we went from minus 5 to minus 2. Okay, now finally I have here at the bottom a chart that actually has both Darcy and the eclipse derived final skin values in the same chart, and you would have expected for them to be obviously fairly close to each other After all, this is the very same inflow definition. There are some minor differences because on the Cartesian grid used in Eclipse, which relates to that Pisman radius inside the block to derive that inflow equation. That's all it is versus the radial uh, coordinates underpinning the Darcy inflow definition. Okay, but other than that minor difference, you would have expected these curves to be fairly close to each other. So there you go, a simple calculator for you to understand the relation between the skin factor and WPI multiplier. Cheers.